morning, students. Lesson 118. We are learning one of the concepts that's probably the most challenging of any of the lessons to teach you how to solve these. It's called completing the square of a quadratic equation, and it is lesson 118, so we don't have many left. 118 and 119 are they're teaching us nearly the same thing, just adding to it in lesson 119. So let's go. Problem number one is not that. We will just do number one because it's from the previous lesson. I want to tell you something here that I may have taught you the other day. I said usually the biggest number comes first, as in here. If you have a inversely problem or a directly problem, I said that usually the big number comes first. In this case, it does not. The difference here is they're talking about a number that is squared. Write that down so that sticks in your head. This problem says that reds vary inversely as yellows squared. When it has that kind of problem, then we put the squared number at an exact position every time. So here we go. I'll show you what I mean. Reds vary inversely. Is that this type of problem? Inversely? Inversely is that type of problem. So we're going to set that up that way. Okay. So we have a equals. The number that is squared is always down here. So we'll put the squared number right there. And so there were 10 reds. That's not what was squared, so we're going to put it over here. But the 100ths, it's set up there that the yellows were squared and the yellows were 100. So we have to put this number down here. And this is where I was different the other day. If it says squared, that number goes down here. Now here's your constant. So we have to solve for this, and with those numbers that we have in position, 100 squared is what? 100 times 100. The simplicity of it is 100 times 10 would be adding 1 0. 100 times 100 is adding 2 zeros. So that's your answer. The K is, I'm sorry, the K is, leave it up here. This 100 squared is 10,000. Now what must the K be? If this is 10, then the K would be, you simply add one more zero up to the top. That would make this 100,000. So the K, we have that's constant. That's where we're at. Now it says, how many reds would there be if the yellows were reduced to 5? And remember, we square the yellows. So we take the 5, square it, which is 25, still with me? 25, and now we take 100,000 and divide it by 25. You can do that on your calculator. I believe that is 400. I'll just make sure of it. 100,000 divided by 25 equals 4,000. And what is 4,000? 4,000 is the reds. Reds equals 4,000. That was number one, not your new stuff for today. Now we go to 8, 9, 10, and 11, and that is your new problems. You'll spend a good bit of time on this, and please be alert and listening carefully because these are very, very difficult. It's a lot of memorization. So here I'm going to write up the original. X squared plus 2x negative 4 equals 0. When we get through with this, we're going to discover that x equals something. And if x equals something, then we can substitute it back in here if we're accurate. And it will complete this same equation. It'll be a solution to this problem. Okay, so we're trying to solve for what x is, and they take us a long road to get there. First off, I'm going to switch this negative 4 to the other side. That's a negative 4, so putting it on this side is going to be a positive 4. And then we go to this number here, and always to find the square of it, you always do this. You always put a 2 under here. And that means 2 divided by 2. No matter what this number is up here, we always divide it by 2. Okay, and then we square it. This is the process, remember, step by step by step. You see what I've just done? Remember that? That's going to happen on every one of these. We're going to divide it by 2 and square it. So 2 divided by 2 is 1. Square 1 is 1. So all of the solution to all of this is 1. We put a positive 1 over here. The next step is simply to add this together. That's 4 plus 1 is a 5. Most times these are fractions that you add together, but you always add those together, and that's a 5. And we put the square root sign on it. Step by step. Did you get that into your computer to there permanently? Always divide it by 2 and then square the whole number. Add that to the other side and put the square root sign on it. Okay, the next step is to simply take x squared. We're going to do x plus what is the solution to 2 over 2? It is 1 equals the square root of 5. Hopefully you're still with me. This was the 1 was the answer to 2 divided by 2. Most times that's a fraction. In this case it was simple, very simple. X plus 1 equals 5. Okay, now the next thing we do is we take x. We want to get x all by itself, just like we've done in previous algebra problems. We get x all by itself, so we move the positive 1 to the other side. It becomes a negative 1, and you will find that it can either be a positive or a negative. Square root of 5 works. There is your answer. Did you follow all the steps? We have 3 more to do, so we'll do the same steps 3 more times, and hopefully by the time we get through with all of those, you'll have those in your head. X equals negative 1 plus or minus square root of 5. Now for that to work, it must fit back into our original problem. So we're going to do that. Here we go. The original problem said that x squared plus 2x negative 4 equals 0. So if this x works, then we will come up with 0. X squared, that's negative 1 plus or minus square root of 5. That's x. And how do we square something? Multiply it times itself. So we're going to go negative 1. I need to do this over here where I have more room. I can do it right here. Plus or minus, I'm sorry. We will just use just 1. We can either use negative or a positive. Either one works. We're just going to use positive 5, 1 positive because of the being confusing. Okay, I'm going to write it down below here. And here we're going to multiply. We squared it. It's a square, so we will take x squared, or this in place of it squared. I'm trying to take this slow enough so you really get what we're doing. All right, here we go. Negative 1 times negative 1 is a positive 1. You agree with that? Negative 1 times the square root of 5 is a negative 1 to the square root of 5. Square root of 5 times a negative 1 is a negative 1 to the square root of 5. Square root of 5 times the square root of 5 is a square root of 25. Let's do this one time. We still have to put x over here also. So now I have a positive 1, a negative 1 and negative 1 is a negative 2 to the square root of 5, and 25 squared is, square root of 25 is a positive 5. Still with me? Still agreeing with me? What I've done? I did it okay? All right, now I'm going to take 2 again times what we said x was. So I'll take 2 times negative 1 positive square root of 5. You got that? We already solved for this x. Now we're going to solve here. We're going to replace the x there with this same thing. 2 times negative 1. We'll put it down here with this problem. Negative 2, I'm sorry. 2 times negative 1 is negative 2. And 2 times this is a positive 2 to the square root of 5. I multiplied that times that. Still with me? Then I have to take the negative 4 and put it down here yet. Now, if we have solved correctly for x, all of this is going to equal 0. I see a negative 2 over 5 and a positive 2 over 5. Put those together, we cancel out. Is that correct? Positive 1 and a positive 6 is a positive, 5 is a positive 6. Those two put together are positive 6. Is that correct? And a negative 2 and a negative 4 is a negative 6, which equals 0. All of this together equals 0. Bingo! This was the right answer. That's what we're doing. This is a complicated lesson. Please take your time and get it well. Okay, here is the answer for number 8. We're going to number 9. Number 9 is x squared plus 3x, and allow me just to simply move that negative 8 over to the other side, and it becomes a positive 8, right? Okay, step number 1, we always take this number and divide it by 2. And then we square it. 3 times 3 is what? 9. 2 times 2 is what? 4. And you see here we always add these two together. Now I have to get common denominators to add numbers together. I got a positive 8 and a positive 9 over 4. So if I put a 4 under here for the same denominator, that changes. The 4 times 8 is 32. So now I have a positive 32, positive 9. That looks like a positive 41 over 4. And remember, we always square root this. Are you still with me? Let that sink in good. And we look at these two numbers and always see if we can solve or simplify these. The square root of 41, we cannot do anything with it, but the square root of 4, we can. What is the square root of 4? It's 2, correct? So I'm going to change this 4, take the square root sign off of it, and put 2 underneath of it. All right, the next step is to come over here, and we will simply take the x squared. We just write, if you remember, we did an x plus this number right here, 3 over 2 equals plus or minus the square root of 41 over 2. Still with me? Final step. X still has this number with it, so we're going to move that to the other side. X equals negative 3 over 2 plus or minus square root of 41 over 2. That is your answer. And again, if you would substitute what we've come up with x back into these where the x's are at, we would come up with a true statement. Right? So here, make sure you got it. This is your answer. That's number 9. You can speed up a little bit, but I knew this lesson was going to take a long time. 10 x squared plus 2x. Again, allow me to put the 5 over there immediately. It's a positive 5. This is 2 over 2 squared. I think you agree that's going to be 1. We've already done that on number 8. So that's where we're at. And the 5 plus 1 is 6. We always do the square root of that one. Now we go back over here. X squared, we're going to rewrite it as a x plus 2 divided by 2 is 1 equals, 1 equals the square root of 6. X, put the positive 1 on the other side, it becomes a negative 1. It's always plus or minus the square root of 6. There is your answer for number 10. One more like this. Number 11. X squared plus 4x equals, again on the other side is a 7. First step is always, we put the 2 underneath of this and then square it. 4 divided by 2 is what? 2. The square of 2 is, 2 times 2 is 4. 4 on this side. This equals 11, square root of 11. Back over here, we take the x plus 4 divided by 2 is 2 equals square root of 11. One more step always. We take the x equals, this goes on the other side, negative 2 plus or minus square root of 11. Do you think you have the step by step by step? They actually have 5 steps that they note. We cut some corners here so that your memorization could work. All right, that's number 9, 8, 9, 10, and 11. Now we'll do several more. 12 is just from lesson 116. This is the original 2 over 7. First thing we do is simplify this. So let's click the square root of 2 is the same as the square root of 7. I can erase this, simplify that. To get rid of the 7, we multiply this times the square root of 7 and this times the square root of 7, which the simplicity of the bottom here is simply just making this the number it was without the square root. Square root of 2 times the square root of 7 is the square root of 14 over 7. Can we simplify 14 anymore? No, we cannot. There is your answer. That's 12. 13 is very similar. Square root of 5 over, I'm cutting corners here now, so you stay with me. That's the same as the original. 13, we just put it into 2 separate square roots. We do this with the square root of 12, and this is the square root of 12, which makes this just the 12 by itself. Now the square root of 5 times the square root of 12 is the square root of 60 over 12. Can we simplify 60? I believe we can. 2, 30, 2, 15. Oh, that's where we have to stop at. We have a 3 and a 5 that would work. So now that makes this a 2 to the square root of 15 over 12. Still there? Can we simplify this? Yes, we can, because these two numbers can be reduced. That's going to be 1 or just nothing over the square root of 15 over 6. We simplified these two. 2 went into both of those. That was number 13. 14 looks a little more complicated, doesn't it? 4 plus square root of 3 over the square root of 6. Lose you. I should have just left this off. This is original. Get rid of the 6. We multiply it times the square, its own square root, and then what we do on the top, bottom, we must do on the top. So that makes this a 6. 4 times the square root of 6 is a 4 to the square root of 6. Is that correct? And now square root of 3 times the square root of 6 is the square root of 18. Continue to erase as we simplify. 6 cannot be reduced, but I believe 18 can. 2, 9, 3, and 3. That is going to be 4 to the square root of 6. And this one is simplified to the square root. Still wrong. Sorry. 3 to the square root of 2. Can this be reduced? All these numbers have to have a number that will go into them evenly, and 4, 3, and 6, it cannot be reduced. Almost looked like it, but not quite. So there is your final answer. That is number 14. And for some reason I picked out 15 yet. Graph this. Yes, this is a little bit something different on the graphing, but you did one step of this. This is taking us to 2 steps of it. And it says that y, let's just do one at a time. There, negative x, positive 2. Remember, we can move this down and put the equal sign in here so that it looks familiar to you. We start off with the positive 2 on our graph, and it's a negative 1 over 1, so that means it's going downhill. I will go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 1, 2, 3, 4. Hope that's not confusing to you, but just trying to speed it up. That's 1 over 1. Let's see how well we can do. Now we'll take this and put this back in here, and that is a less than or equal to negative 6 plus 2. Y is less. In your mind, is it going to be on this side or this side that we shade? If y equals less than. Seems to me like more than is up and less than is the downside. So I think we will shade, because it's less than, I think we're going to shade this. But now we don't shade that immediately. We just know it's in this area on this side. So keep that in mind, on this side. But they give us a second one to do. Y is greater than or negative to x. Okay, so we will solve for this. We don't have a number, so we start off at 0, and it's positive, so we're going uphill, and it's 1 over 1, so I can go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 in here. From here, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Is that a straight line? I hope it is. Okay, so we knew that we're shading on this side, but now we divided this side up into 2 different pieces. And here it says that y is greater than x. In these 2 pieces, which one would you think was greater than? It seems like up this way would be greater than, wouldn't it? Y is greater than, then this should be less than. So first off, if you noted, without the second line, we had this side, and now we're saying this side. So here's what we're doing. We're shading this in on that block right there. 2 steps to this. That's kind of neat, isn't it? And you can check yourself out by taking any point in here, and you could go 1, 2, 3, 4, 1, 2, 3, 4. You could do this a negative 4 and a positive 4. Use that set, and that would work in both of these equations. We won't take the time to check ourselves out on that. Video is running. That is all that I chose to do for you today. If you do have problems, I'm always here. You can give me a call, and maybe I will respond back as quickly as I can. That is 118, and if you look at lesson 119, it's just a continuation of what we learned today, so hopefully 119 will not be quite as in-depth. Yeah. Okay, thank you. You have a wonderful week.